welcome to this next video on section 6.2, and I'm actually going to split up 6.2 into two videos. The first one is on multiplying rational expressions, and the main idea that we need to remember here is that when we are multiplying rational expressions, same thing as when we're simplifying them. Let's make a little note. When we're simplifying rational expressions, we want to factor first. So again, it's important, very important, that you have down the skill of factoring, because we're going to have to factor in this first problem here. I'm going to have to factor 1, 2, 3, 4 times in order to simplify and solve this problem. So let's go ahead and look at this first example. I have now two rational expressions, one here and one here, multiplied by each other. And the first thing we want to do is factor. So if I factor the numerator, I have, for this first one, I have x and x, and then I got to have a 2 here, so it's got to be, and this is -3, so this has to be x minus 2 and x minus 1, because -2 times -1 equals 2, and -2 plus -1 equals -3. Okay, now the bottom factors into x plus 3 times x plus 5. And then we have to factor the second expression, which is very similar to the first part. Actually, I didn't realize this when I wrote out this example. It's going to be pretty obvious, I think, what's going to happen here, because notice that these two are exactly the same. That was unintended. But we have x plus 3 and x plus 5, so we don't even really need to factor here, because these two are basically just going to cancel. This is going to cancel with this, but I already did the factoring, so I'm not going to erase it at this point. So we have here, we got to have x plus 4 in this denominator and x minus 1. So now I can look to try to cancel things. I have an x minus 1 here, which cancels with an x minus 1. I have an x plus 5, which cancels with an x plus 5. And an x plus 3, which cancels with an x plus 3. Of course, we already knew all of those were going to cancel. And so we get a final answer of x minus 2 over x plus 4. And again, just like in the last video, I'm going to go ahead and ask if I can cancel these x's. You should be thinking right now to yourself that no, you cannot cancel those x's, because they each have a number attached to them, and unless those numbers are exactly the same, we cannot cancel. So that's our final answer. Okay, so that's the first example. Again, factor first. Now this next one is kind of similar, except that I have a rational expression times a trinomial. But I can turn this trinomial into a rational expression if I just put it over 1. So I'm going to go ahead and do that. And then again, what do we need to do? Factor first. So this top one, factor out the GCF of 7, and I'm left with x minus 3. And in the denominator, that factors into x minus 6 times x minus 3. X minus 6 times x minus 3. And then that polynomial expression factors into x minus 6 times x plus 2. One thing I just want you to note is that you can kind of start to, once you've factored one of the rational expressions, you can look and see what kind of factors you have here to help you in how to factor other parts of your multiplication. Because in this polynomial, notice there's an x minus 6 and an x minus 6. If I'm thinking I might be able to factor or cancel out x minus 6, and there's a good chance that this polynomial has an x minus 6 in it, which means this must be x plus 2. And sure enough, it works out that way. This is over 1. And then again, I look to cancel common polynomials. I have this, x minus 3, and x minus 6. And so all I'm left with is on the top here, I have this 7 and this x plus 2. So 7 times x plus 2. And then in the denominator, I just have 1, which I don't need. That's our little skinny man that likes to hide, right? We don't need him. So we're just going to leave our answer as 7 times x plus 2. Alright, so I have one more example here. My last example, again, our first step should be to factor top and bottom. First expression, rational expression, I want to factor out a y, it's a GCF, which leaves y plus 2. And then on the bottom, we can not factor anything. There's no GCF, it's not a trinomial, so we're just going to leave it as 3y minus 1. And then this is being multiplied by another rational expression, which happens to factor with 2y and y at the front to get 2y squared. And then here we got 35, which is probably going to be 7 and 5. And sure enough, if I write negative 7 right here and positive 5 right here, I show a little check. This gives us 5y. And this gives us negative 14y, which adds to give us negative 9y that we wanted. Okay, and then in the denominator, again, we're going to have a 2y and a y to get 2y squared. Hopefully your factoring skills are getting better as we've done more and more of these. And then to 28, it's probably going to be 4 and 7. And if I happen to pick a minus 7 here and a positive 4, it works out because we get 4y and negative 14y, which add up to get us negative 10y. So we can now look to go ahead and cancel our common factors. We have y minus 7 and y minus 7, and it's not looking like a whole lot else is going to cancel here. We don't really have anything else that I can see. We had 2y plus 4, 2y plus 4. Nope, that's as far as we can go. However, what sometimes might happen is that because when we're doing rational expressions multiplying by each other, we can end up with two new expressions here. It's sometimes a good idea to go ahead and multiply these back out and try to refactor. Sorry, I had a little interruption there. Notice that we, in this polynomial expression right here, I can factor out a 2. This actually simplifies down into, and we should have done this from the very start here, there's a GCF here. Notice that this can factor out a 2, leaving y squared minus 5y minus 14. Well, because we didn't do it at the start there, we could have factored out a 2 here, leaving y plus 2. We can still factor that 2 out. So what's left? this got replaced with this, but then this y plus 2 can cancel with this y plus 2. And so in the numerator we have y, that's this guy, times 2y plus 5 over just this one, 3y minus 1. And that's our final answer.